innovation. Our next presentation will be from Professor Tim Broyd, Director of the Institute for Digital Innovation in the Built Environment at UCL. He is also Fellow of the Royal Academy of Engineering, a chartered engineer, Fellow at the Institution of Civil Engineering, and also Fellow of the Royal Society of Arts. He will be speaking on the digital transformation of construction and infrastructure. Please join me to welcome Mr.
Well, good afternoon, ladies and gentlemen. It's an honor to be invited here to this conference this afternoon. Since one or two of my predecessor speakers were bandying sizes and ages, I'm happy to say that UCL, which is a global top 10 university, is in its 200th year, 200th anniversary, so it's a bicentenary year. The Institution of Civil Engineers, which I cannot speak for, but was a president of, was founded in 1818, which makes it the oldest professional engineering body in the world. Currently has about 100,000 members worldwide. I am proud to be a visiting professor at both Tsinghua and Chongqing universities. Tsinghua is mainly concerned with project management and productivity. Chongqing University is mainly concerned with the development of sustainable urban areas. I must move on quickly. Must be that one. Is it that one? No, it's that one. So these days we're pretty used to seeing diagrams generally as models of this nature. And we've come there very quickly, right? This is, before I get on to that, sorry, and yet we still have many challenges for construction. So this slide I have stolen from one of my good friends, construction director at the UK government. I do not speak on behalf of the UK government, but I'm informed by what they say. And so the challenge for construction, demographics. Within the next 40 years, we're anticipating nearly 9 million more people in the UK. At the moment, currently about a third or over a third of UK construction workers are over 50. We need to change. Productivity, the graph on the left, is typical of many you'll find in certainly the Western world, throughout Western Europe and the USA, showing that compared with overall economy or manufacturing, which are the higher lines, construction over the last 20 or 30 years has bubbled along the bottom. Despite all the changes we've made on greater automation, greater efficiency, etc., apparently we're still no more productive now than we were 30 years ago. Talking of which, change has come fairly quickly. I mean, this is a slide I gave. It was an invited lecture at the Institution of Civil Engineers. I was working there in those days for a company called Atkins. By the way, I've been a university academic, if you like, for about 12 or 13 years. I was in industry for 33 years, so I'm still very biased towards industrial culture. But at that time, 1999, we were looking to get away from the standard model where every stakeholder on a job had to send paper information to everybody else. And we were looking for some sort of way when we could have a shared project model in the middle with stakeholders giving to and taking from a single body of information. Move on a few years. The UK government had a new construction strategy, and as a part of that strategy, and you probably won't be able to see the words here, we had a senior government minister state that part of this strategy is that within 5 years' time, so by 2016, all construction and infrastructure procured by the central government in the UK should be undertaken in a three-dimensional, in the words then, it was level 2 BIM environment. Why? Because this was a new government. They'd taken over from the previous lot who had used all the money? I kid thee not. So a new government coming in, wanting to do quite a lot, including quite a lot of building, and they were convinced then that using BIM techniques would save both capital cost and, in the longer term, operational costs. And just my definition of BIM, there are many around, there are some in standards or whatever, but to my mind, BIM is a software-enabled set of processes integrating information over the lifetime of a project, requiring close collaboration. Now, we sign contracts between people. Doesn't mean we have to collaborate. I have a contract I signed with my wife 48 years ago. It's a marriage certificate. It doesn't say I have to love her, but I do. But just because companies sign contracts doesn't mean they need to get on with each other. But for BIM purposes, they need to find a way. And of course, we don't always have to consider just new buildings or structures. This is the world's first bridge made of iron. It's at a place in the West Midlands of England, which has become called, funnily enough, Iron Bridge. If you look at how it was made as if wood was the material, because there were no rules at the time for working with iron. It's still there, it's still operating. We have to make sure it keeps operating, so we need to understand how to manage the asset. A challenge is, though, we're not used to thinking in lifetimes, right? This is a set of plans of work from many parts of the world. I don't think China is here. Where, as you go along the top, pre-design, design, construction, handover, in use, and end of life. So we have Reba, halfway down. We have a load of other countries. Nearly all of them kind of peter out at handover, right? Some of them go in, but not very deeply, into the operational area of life. None of them go as far as end of life. Do we change the use? Do we pull down, etc.? What's important about this particularly is that the in-use area is by far the longest in time, it's by far the most expensive in money, and it's by far the most carbon generating. And yet we're not brought up to think in those terms. It's tricky. If you look at world global projects, this is a graph from a few years ago. My apologies for that, but it still counts. You'll see there that as a review of quite a number of large projects in oil and gas, energy, real buildings, infrastructure, etc. The average delay on a large project is 20 months, right? The average cost increase is 80%. That's where the dotted lines intersect. Top right, you've got some real Lulus of projects, right? Years late, factors over time, etc. It's not just the UK. This is a global issue. Right? If we look at one particular project and some of the challenges working with new tools and techniques gives you, this is a schematic of Crossrail, right? Which at its time it was finished. Train started running. It's now the Elizabeth line in London. It goes from Reading in the west, which is further than Heathrow Airport, to somewhere quite far east of London, with the main part under London being in tunnels, right? Not an underground line, like a London Underground line. It's a mainline rail line. So you can think of this in terms of a number of details there, right? 37 upgraded or new station, 19 boroughs passed through, which means it had to get planning permission from every single one of 19 London boroughs individually. 5 main tunnel lines, 1 world-class railway. You can look at it then as a physical entity. 42 kilometers of tunneling under London, looking for 200 million passenger journeys per year, etc. 24 trains per hour in the central section, so that's one every, 2.5 minutes, something like that. You can look at it as a digital railway, 250,000 individual CAD models, 4 million documents, 1 million assets and pieces of equipment, 500 million GIS, geographical information system features, and a price that came out in the end at about 21 billion pounds. At the time, the largest project in Europe. Look at the information management system they use. Well, that's pretty close to the one I was searching for in 1999. So a common data environment, electronic document management system, electronic content management system, master data management. And the principal thing here is that for these types of large infrastructure projects in the UK, the client will own the system, the client will own the data. Who is the client? These days, that is a single-purpose vehicle company that is put together to deliver a railway, right? So Crossrail Limited was the entity that was founded specifically to develop not the tunnelling system, but the whole railway. But that's a long project. You know, London is a complicated city. If you look under the ground at London, it is very complicated, right? There are lots of things underground, and of course, a new railway has to try to miss them all. Yeah. So if you look at you can see the timeline going from 2005 to 2019. There were different types of work. I won't go through them. One's engineering, one's systems integration, etc., etc. The pinkish one, but the money available went up and down according to what the UK government thought it could afford, right? The BIM mandate came in towards the end, but there was a lot of preparation for it, so the project had to withstand a lot of new standards. How to do BIM, how to do this, how to do that, as they were introduced. And at the top, because of the length of the program, smartphones were introduced first in 2007, tablets 2010, wacky glasses if you wanted to try those a year or two later, the whole lot of Internet of Things towards the end, and of course these days it will be AI, AI, AI. So all of these things had to be taken on board by this one project as it tried to deliver. I mean, the fact that it came through maybe a couple of years late and maybe a couple of £billion over is not surprising to me. Right, moving on a bit on digital twins. These have been around for a while, and the benchmarks that I've certainly used have been aviation and Formula One, where Rolls-Royce were the first to provide, not to sell engines, but to provide power by the hour, with a lot of the bits and pieces of the engines having sensors that took information and telemetred them back to Rolls-Royce home base, so that if a plane was going a bit out of sorts, the engine could be repaired when it landed. Formula One, of course, lots of data going from the car back, some of it to the racetrack, a lot of it back to wherever the team is based. We don't seem to have that so much in construction, right? But then digital twin, to my mind, has become a new buzzword. It's like sustainability, right? Sustainability is too often now treated as a buzzword with people missing the main intent. So, UK's National Infrastructure Commission, what is a digital twin? A digital twin is a computer model which mirrors and simulates an asset or a system of assets and their surrounding environment. To my mind, if BIM is a geometric model of a project, then a digital twin is a performance model. Right, that's the main difference to me. Do we do much? Not really. I mean, here's an example from London, a building called the Hickman, which was a building which a property developer bought, put a couple of stories on. It's not a high building, as you can see. And then looked to combine a number of different systems, I'll go through them in a minute, into one building in real time. So the digital twin there, fully integrated with the building management system, continuously monitoring over 14,000 points in the building, connected to the original BIM model and the operation and maintenance manual, linked to the CAFM, that's a computer-aided facilities management system, data stored in what they call a data lake, hopefully one in which they can find bits and pieces they need, etc. Right? And this used to provide energy real-time data against simulations. And then the idea is you tune the model to fit the building rather than the other way around. Right? If we look into digital technologies generally, the line on the left, the graph on the left, shows over a period from 2009 to 2019. The low line at the bottom is venture capital without construction technology. The line that goes right up is construction tech venture capital. Huge amounts of money going into this. And the good people, McKinsey, I think, yes, who put this together, will come up with little islands of good stuff that's usable by construction. And if you look further, then the potential applications in the construction industry are pretty much everywhere, going through machine learning, computer vision, etc., different types of AI. But then we come to what actually happens, right? So one of my recent PhD students set out to look at automated compliance checking for the design of a hospital, right? At the moment, it takes many experts, many months to do, costs a lot of money. So can ACC, using machine learning, natural language modeling, used to be called large language modeling, can it assist with this? Well, basic steps, fairly simple: problem identification, data pre-processing, etc., etc. I'll skip that one. But what this has to chew up, what this has to take in, are, at the top line, a number of British laws, acts, we call them, right? Health and Safety Care Act, Health and Social Care Act, Care Quality Commission regulations, Building Act, and building regulations. And these come down to a nest of other guidelines, etc. And there's something like 200 of them, right? Combined with that, if you look at just the Building Act and the building regulations, then you've got document statutory guidance, which means you've pretty much got to adhere to it. There's not so much guidance as direction. You've got documents A to whatever, covering different areas. And some of those are multiple volumes. So approved document L, towards the right, has 4 volumes in itself. And that's the one that covers insulation, ventilation, thermal efficiency, all of that. So how did my student do? Well, she did better than anyone had before, right? Which gives a big tick and a PhD. But the measures used come from computer science. So she got an accuracy of 81%. What does that mean, right? Does it mean 81% was absolutely perfect and 19% was rubbish? She got an F1 score of whatever. What on earth is an F1 score? It's nothing to do with motor racing. Right? So I think we need to get a new language for how we interpret the things we need to do in construction from what has been for too many years the province of computer science. And if I'm not being too rude to them, they are more interested in the techniques and the processes than in the applications. Okay. So what are my thoughts on AI overall? I tell you, this is an overall big picture glimpse, as it were. AI for construction. Interpolation is fine, but extrapolation very questionable. 1 minute, maybe 2, perhaps. What do I mean by that? If you've got a body of data, if you want to take data from within that body, it's absolutely fine. But if you want to think of, use it for other purposes, let's say the climate's changing. We've got loads of data going up to, 25 degrees. We want to have a look at what happens at 35 degrees. We don't have that. You can't do that using AI. Historically, certainly in the UK, historically unstructured, data rich. That's what we are. We've got a lot of numbers, right? But we're information poor, right? I mean, there's a standard triangle that goes data, information, knowledge, wisdom. We've still got far too many data, which haven't been measured in the same way by different people at different times for the same sort of thing. Integrated information therefore needs to be consciously collected. You can't try and make up things that you haven't got. Right? 4th bullet point, technologies such as digital twins, blockchain, AI are poorly understood and very poorly used in industry. I've got a current PhD student who set himself the task of working out what a cost-benefit analysis of a digital twin is. And he's interviewed many, many senior people in different sectors. None of them have a clue. So we're developing one ourselves to see what the market thinks. So DT is increasingly in use, but do people really know what they're doing? Academic research, well, I would say this, wouldn't I? Academic research needs to infect industry practice, right? We need to make sure that what we do in academia is transmitted into industry. Because otherwise, what's the point, right? As I said earlier, I've had 3 decades, more than 3 decades in industry, so maybe naturally I would say, well, let's get the goodies out and use them. But we need better ways of doing that. I think I've just got a couple more slides. Again, wise words from what the UK government wants. Every now and again it sends out encouragement in the form of recommendations. So, transforming infrastructure performance in 2017, consultation on platform DFMA. Well, DFMA is design for manufacturing and assembly, okay? P is with a platform. So the ideas we've been looking at then over the last few years have been, can we do in construction what automobile manufacturers do? So you buy a Volkswagen, maybe 3 separate models have the same floor plate, right? Construction playbook, nothing about playing. This is really guidance for government procurers on what they should look for in construction. That's about to come out as its 3rd, maybe 4th edition, and I've been involved in 3 out of 5 steering panels for that. And then going from transforming infrastructure performance to a roadmap in 2021. So we get lots of encouragement. We don't get that much help. What are the drivers for digital change? I'll run through these very quickly. Low productivity, poor quality, skill shortages. I mentioned these earlier. The construction playbook, TIP, transforming infrastructure performance, digitization, industrialization, and the government has recently released a 10-year infrastructure strategy which commits it to spending nearly nearly £1 trillion over the next 10 years. 2/3 of which will be on energy, right? So it's not balanced across all types of infrastructure. Right, lest we forget, if we get things wrong, I will go over that for the sake of time. If we get things wrong, we get things badly wrong, right? So this is a tower of social housing, which is housing for people with not so much money, which burnt down in 2017, causing 72 deaths. Why did it go on fire, take fire quite so rapidly? It's because external insulation had recently been installed, and the insulation provider lied and sold flammable insulation. There were other problems as well. Yeah? Year after that, the Morandi Bridge in Genoa, well, the yellow bit on the right, fell down after a period of heavy rain, 43 deaths, some of which people in apartments below the bridge. Right? So a constant need to make sure our assets are alive and well. Just as a last point, we launched an MBA on major infrastructure delivery a couple of years ago now, aimed at mid-career professionals working in very large projects who want to get a kick ahead to help them lead large projects. It's got 8 main modules covering a lot of things, so procurement, governance, designing client organizations, etc. One of which I run on controlling information and systems. Thank you very much.
Thank you, Professor, for your such inspiring presentation.